Hello, welcome to the chapter number 2 of Algebra. And in this chapter, we will talk about the system of linear equations. Okay, let us suppose that we have a system of linear equations. So when we talk about the system of linear equations, two things are important. The first thing is number of linear equations, and the second thing is the number of variables. So these two things are very important if we have a system of linear equations. So the two things are important. The first thing is number of equations and the second thing is number of variables. Okay, so in this scenario we will suppose that the number of equations are m and the number of variables are n. So we will use these two indices throughout these chapters. So number of equations will be represented by m and the number of variables will be represented by n. Okay, so suppose that we have m number of equations and n number of variables. Then we can write them in this way. So the first equation, here first I will write the first equation, x1 plus x2 plus x3 plus up to so on plus xn. Since I need n variables, so in the first equation I have written n variables, x1, x2, x3 up to xn. So I have written n variables. So this is the first equation. So for each variable I have to write some specific constant or the coefficient. Suppose the coefficient of the first variable is a11. Suppose that the coefficient of the second variable is a12. And for this it is a13 up to so on. For this it is a1n and it is equal to some constants. Suppose that that constant is b1. Okay, similarly I will write the second equation. For the second equation I will again write the same constant x1, same variables, x1 plus x2 plus x3 up to so on plus xn is equal to, here I should write b2, but the constants or the coefficients should be in this way: a21, here a22, here a23 up to so on, here a2n. You might have noted that in the first equation there are two indices of the coefficients. So in the first equation the first index is 1. You can check here the first index is 1, here the first index is 1, here the first index is 1, here the first index is 1. And similarly in the second equation the first index is 2, the first index is 2, the first index is 2, the first index is 2. So except these things there is no change in both equations. Okay, so you can check that only the first index has been changed to make the new equation. So if I have to write the next equation, I have to write the same equation, but I will change the first index by 3 because I have to write third equation, right? So here is the third equation. I will write again x1, x2, x3 dots, and then xn is equal to b3. I will write a31, a32, a33 up to a3n. And similarly, I will write more equations. And the last equation will be, okay, you can check that this is equation number 1. This is equation number 2. This is equation number 3. How many equations we have? We have m equations. So the last equation must be equation number m, because we should have m equations. Okay? You can check for the first equation. My coefficients are a11, a12, a13 up to so on a1m. So for the second equation, the first index is 2. For the third equation, the first index is 3. So what will happen for the mth equation? So it's obvious that for the mth equation, the first index must be m. So I should write am1 x1 plus am2 x2 plus am3 x3 plus up to so on plus amn xn is equal to bm. So this is equation number m, the last equation. So this whole system is called the system of linear equations. Again, if you look that along each row, the first index of each coefficient is same. For example, for the first row, for the first equation, the first index is 1. And for the second equation, the first index is 2. For the third equation, the first index is 3 in all of the coefficients. And similarly, along the last equation, the first index is m. But if you look along columns, so for the first column, the second index is 1 for all the terms. And for the second column, the second index is 2. And along the third column, the second index is 3, because this is column 3. This is column 1. And this is column 2. And this is column 3. And up to so on, along the last column, think how many columns are there. So it depends how many variables are there. You can check. This is the first variable, this is the second variable, this is the third variable, this is the nth variable. So there are n variables. So that means there are n columns. So this is nth column, column n. So you can check along each column, the second index is same. Okay. So it depends in which column that coefficient is lying. If it is in the first column, the second index is 1. If it is second column, the second index is 2. If it is third column, the second index is 3. Nth column, the second index is n. Okay. So along row, the first index are same for each row, and along columns, the second index are same. Okay, so in this way we can make a matrix, or we can convert this system into matrix form. So in order to convert the system into matrix form, First I will write the coefficient matrix, then I will write the variable matrix, and then I will write the equal matrix, or I will write the constant matrix. Constant matrix is represented by B usually. So I will write here for A the coefficient matrix, for X it is the variable matrix, and B is the constant matrix. Okay, so let me write A first. So in order to write the coefficient matrix, let me go back to the equation. The coefficients are A11, A12, A13 up to A1n. Let me write that. A11, A12, A13, A1n. And for the second equation, it is A21, A22, A23 up to A2n. Let me write A21, A22, A23, A2n, and then A31, A32, A33 up to A3n. And similarly, I will write the last row, which is AM1, AM2, AM3, AMN. You can check. This is the last row, AM1, AM2, AM3 up to AMN. So I have written all of the rows of all of the coefficients here, and this matrix is called the coefficient matrix. Then I will write the variable matrix. Since there are only n variables, which are x1, x2, x3, xn everywhere, so I will write n variables. x1, x2, x3 and xn. And the last matrix is the constant. Since there are m constants, which are b1, b2 up to bm, so I will write B matrix is equal to b1, b2, b3 up to bm. So this is the constant matrix. Okay, so this is the system of equation, and we will write in this way. The system of equation can be written as Ax is equal to B, where A is this matrix, B is this matrix, X is this matrix, and B is this matrix. Okay, this is the way how we write the system of equations in matrix form. So if we have to solve this system of equation, what we will do? We will write a new matrix which is called augmented matrix. So what is that augmented matrix? The augmented matrix is a new matrix which is obtained by adjoining A and B in this way. Okay, let's look how we adjoin these two matrices. So here we have A adjoined with B. So how will I write? First I will write A, and then I will make a line, this line, you can check this line, and then I will write matrix B. And this matrix is called augmented matrix. So what we have done, we have first written matrix A and then line, and then we have written matrix B. Okay, So this is the way how we write augmented matrix. You will be given a matrix, a system of linear equations. You will be given matrix A, you will be given matrix B. What you have to do, you have to write A, line and B. Okay, just like I have done here. Okay, once you have done this thing, then you will solve it by some methods. There are two main methods. The first one is called the row echelon form, and the second one is called row reduced echelon form. We will solve both of them. But in order to go to the methods, first look at some examples. So the example is, in this example we are given a matrix and the variable matrix and the constant matrix. You know, this is A, this is X, this is B. Because I told you we have AX is equal to B. So we are given both matrices which are required, which is, the one is A, the second one is B. This is variable, so this is not important for us. So what we have to do, we have to find an augmented matrix. So what is augmented matrix? So I told you, whenever we have this system of equation or in matrix form, we have to find an augmented matrix. So what is augmented matrix? It is A, line, B in the matrix form. So how to write this matrix? 2 minus 3 2, and then minus 4 5 4 minus 6, then 3 minus 2 9, and then 1 1 minus 3, and then I will make a line. At the end I will write the constant matrix. The constant matrix is this one, minus 7 6 3 0. This one is also 6, and this is augmented matrix. And this augmented matrix is important because it has information of the system of linear equations in one matrix. Okay, this is also important because these are three different matrices and this is only one matrix. So this is important because only one matrix contains all of the information of the system of equations. Another important thing is that it is also important because this matrix is used to solve the system of linear equations, because we will be using operations. Those operations will be sometimes row operations and sometimes they will be column operations, but I will probably give you only row operations. Okay, we will not use the column operations, but whenever we need we can use the column operations, but our main focus will be on the row operations. Okay, and also we have the visual separation of coefficients and the constants, because we always understand that the last column is the constants and the first whole matrix is the coefficients, because this is the constant matrix and this is the coefficient matrix. This is just the way we have defined above. You can check from here. This is the coefficient matrix, this is the constant matrix. Now we have another practice problem. In this practice problem, we are given the extended matrix is, we are given an augmented matrix. Sometimes we call it extended matrix or sometimes we call it augmented matrix. So the augmented matrix is this way, 3 0 0 0, 2200, 1110, and 0 minus 1, 1 1, and the last column is 27 3 1. And we have to solve this system. Okay, so this matrix, this augmented matrix is in pure form. You can check that this is the main diagonal. This is the main diagonal, and in order to solve, okay, look at the previous example. The main diagonal was this. We need everything below the main diagonal 0. Okay, since here is nothing 0, the things which are down, which are below the main diagonal, are not 0. So that's why we have to perform some operations to make them zeros. Okay, but here in this example, we below the main diagonal everything is 0, so there is no need to perform operations. We will just find the solutions. Okay, so whenever we will be given such kind of matrices, such kind of augmented matrix, what we will do, we will find the main diagonal first, as we have found here, the main diagonal, this one, and after that we will make everything below 0, and if we are able to do that, then we will go to the solution. Okay, so here everything below the main diagonal is already 0, so the solution is very easy here. So how we will solve it? We will compare this first row is corresponds to the first variable. First variable, for example, is x1. The second variable, for example, x2. This is, for example, x3, and this is, for example, x4. Okay, so if we compare the last row, in the last row I will write 0x1, 0x2, 0x3 plus 1x4, okay, is equal to 1. So from the last row I will write, from row 4, what will I write? 0x1 plus 0x2 plus 0x3 plus 1x4. So 0x1, 0x2, 0x3 plus 1 times x4 is equal to 1. So what does that mean? This means x4 is equal to 1. So we have found the variable of the last variable, the value of the last variable. Okay, so similarly we will use the row number 3. Now from row 3, what will I write? 0x1 plus 0x2 plus 1x3 plus 1x4 is equal to 3. Okay, I will write these things. 0x1, 0x2, 1x3, 1x4 is equal to 3. What does that mean? That means x3 plus x4 is equal to 3. Since x4 is equal to 1, so I will put here x4 is equal to 1. This means x3 plus 1 is equal to 3, and then I will take this one here. Here I will only left with x3, and x3 will be 3 minus 1, which is 2, which means x3 is 2. Now I will go with the second row. This means 0x1 plus 2x2 plus 1x3 minus 1x4 is equal to 7. Okay, so I will write 0x1 plus 1x2 plus 2x2 plus 1x3 minus 1x4 is equal to 7, which means 2x2 plus x3 minus x4 is 7. Since I know that x4 is 1 and x3 is 2, I will put their values. Since x3 is 2, so I will write here x3 is equal to 2 minus, since x4 is 1, you can check from here, we have already found. So I will write 2 minus 1 is 7. 2x2 plus 1 is 7. 2x2, I will take this one here, I will get 7 minus 1, which is 6. Now I will take this 2 here, because 2 is the product, is being multiplied with x2. If I take to the other side, we will divide by 2. Okay, so x2 is 3. So I got x2 equals 3. Now I am able to compare the first row, which is 3 times x1, 2 times x2, 1 times x3, 0 times x4 is equal to 20. Okay, so what will I write? 3 times x1 plus 2 times x2 plus 1 times x3 plus 0 times x4 is equal to 20. So this is obtained from row 1. Okay, and this is obtained from row 2. Okay, now this is equal to 3x1 2x2 plus x3 is equal to 20. I know the value of x2, I know the value of x3, because x2 is 3 and x3 is 2. I will put their values here. 3x1 plus 2 times x2 is 3 plus x3 is 2 is equal to 20. Here you can see x2 is 3 and x3 is 2. Okay, now if we solve them, 3x1 plus 6 plus 2 is 20. 3x1 plus 8 is 20. 3x1 is 20 minus 8, because I will take this 8 to the right side, and this is equal to 12. Now I will divide both sides by 3. So x1 is 12 by 3, which is 4. So x1 is 4. Hence, the solution is x1, x2, x3, x4. What are the values? Put their values. x1 is 4, x2 is 3, x3 is 2, and x4 is, I think, 1. Let me check. What is x4? X4 is 1. Yes. So this is the solution.